Hey, what's going on, guys? Today we're going to be doing question 997, find the town judge. LeetCode daily question for today, 2022, January 2nd. This question is being asked by Amazon and Google in the past 6 months. And pretty much what it's asking is you have to find the person that satisfies these three conditions. It's that means they're the town judge. So whenever we're given an input that has a list of relationships between different like objects or nodes, and we think about it as a graph question. So for example, 2, right? The input is 1, 3, which means 1 trusts 3, right? So that's node 1 going to node 3, and then we have 2 to 3 like that, and we need to find the node that doesn't have any that satisfies these two conditions, which is it doesn't have any outgoing edges, and it also has all the incoming edges from the other people except for itself. So in this case, it would be 3, right? Because the in degree of node 3 is 2, but out degree of node 3 is 0, right? So in degree would be for the second condition, right? So second condition, everybody trusts the town judge, which means everyone has a edge going towards the judge. So if you have n persons, then that would be n minus 1 edges going towards the judge, because you don't count the judge himself. And then for the first condition, it means the judge trusts nobody, so the judge has a 0 outgoing edges. So it's pretty simple. We just have to go through the trust input, the array once, and then go through it again, checking each person. So we'd have a O of n solution, where n is the length of the trust input. Okay, let's go to the code. So we're going to keep track of the in degree and out degree of each person or node. So in degree, and there's going to be n values, and first initialize them all to 0. So now we need to calculate or find out how many, what's the in degrees, out degrees of each node or each person, given the edges, which is the trust list. So the first value is where you're coming from, so that's A. Second value, B, is basically where you're going to, so that's like, you know, where the arrow is going to point to, like right there. So we're coming from T0, so that means the out degree of this one here from will be incremented. And then the in degree of 2 is incremented because we're going towards this this value, this node here. Okay. Oh, and we need to minus 1 because our arrays are 0 indexed, while the input is given from 1 to n, so just minus 1 right here. And later we'll have to increment by 1 for our answer. So now that we know like the in degrees and out degrees of every single person, we can just check to see if which person would be the judge. So checking for these two conditions. So first one is the judge trusts nobody. So this means the out degree of I is equal to 0. And second condition, everyone trusts the judge, means the in degree, right, would be n minus 1, right? Because you have n persons, and everyone trusts the judge except for the judge itself, so n minus 1. So just if out degree of I is equal to 0, and in degree is everyone else, so n minus 1, then that means we satisfied the conditions for the judge, and that means person I is the judge. And return I plus 1 because we initially offset everything to be 0 because our array's index is 0. So we go through all the possible percents, and if we don't find anything, we just return -1. Okay, let's see if it works. Okay, making sure. Alright, looks like it's good. Alright, there you go. Solution is O of n. Space complexity is O of 2n. Just keeping track of the in degrees and out degrees for each person, so that's just O of n as well. Thanks for watching. Let me know if you have any questions or comments, and I'll respond to them.